NRC rule shift opens door for next-gen nuclear designs. The U.S. nuclear sector is entering a different phase, less about theory, more about whether new designs can actually clear regulatory hurdles. The Nuclear Regulatory Commission's finalized 10 CFR Part 53 is designed to better match how next-gen reactors are built, not how legacy plants operated. Within days of its release, startup AMPERA signaled intent to move quickly, initiating early discussions with regulators around its thorium-based microreactor. Its February submission begins a pre-application process for a containerized factory-built system intended for modular rollout. The timing reflects a broader shift across the industry. Smaller, more flexible reactors are increasingly positioned as complements to large-scale nuclear rather than replacements. Regulation meets reactor design. Part 53 marks a structural change in how nuclear projects are assessed. Instead of forcing advanced concepts into frameworks built for light water reactors, the rule shifts attention toward performance and safety outcomes. For developers, that could mean fewer workarounds and a more direct path to licensing. AMPERA is framing the change as a practical step forward. The company is aiming to focus its licensing case on the specifics of its design, rather than spending time reconciling it with legacy regulatory categories. Its approach includes embedding artificial intelligence into system architecture, particularly in areas tied to safety monitoring and safeguards. The NRC engagement itself will cut across multiple domains, including reactor oversight, materials handling, and fuel cycle considerations. AMPERA's pre-application work is expected to outline its safety methodology, proposed timelines, and how it plans to structure ongoing interaction with regulators. A pre-application meeting targeted before the end of May is intended to align expectations early, a modular bet on nuclear's next phase. At the center of AMPERA's concept is a subcritical reactor using thorium fuel and triso particles, paired with what it describes as a hybrid fusion-fission system. Subcritical designs rely on an external neutron source, which proponents often point to as a built-in safety advantage. The company is also emphasizing passive safety features and reduced refueling requirements. Just as important as the technology is the deployment model. Factory fabrication and containerized delivery are meant to limit on-site construction challenges and shorten timelines. The approach also opens up a wider set of potential applications, including energy supply for data infrastructure, defense operations, and maritime use. Its licensing strategy reflects that flexibility. Alongside technical documentation, the company is prioritizing early, structured dialogue with regulators to define scope and review pathways before formal applications are submitted. Progress with constraints. Even with a more adaptable regulatory framework, advanced nuclear projects still face familiar constraints. Safety remains the baseline, but commercial viability, manufacturing scale, and operational reliability will ultimately determine whether designs move beyond pilot stages. Part 53 may reduce friction, but it does not lower the bar. For concepts like thorium-fueled or subcritical systems, where large-scale operational data is limited, regulatory scrutiny is likely to remain detailed. Early movers such as AMPERA will effectively test how the new framework performs under real-world conditions. The broader takeaway is less about a single company and more about timing. Regulatory systems are starting to align more closely with emerging technologies. Whether that translates into faster deployment will depend on how well developers can navigate and validate within this updated landscape.